Today we are going to understand one of the most important equations in mathematical physics. This equation describes sound wave, earthquake wave, electromagnetic and many other physical phenomena. This is three-dimensional equation. The left side represents the acceleration of the wave in respect to time. The right side describes how the wave changes in the x, y and x direction. Now let's understand the meaning of every symbol in 3D wave equation. The function wave represents the displacement of the wave. For example, in water waves, it tells us how high or low the water surface at any point. The second derivative with respect to time measures the wave acceleration, how quickly its motion changes. The symbol c in the wave speed, a larger value of c means the wave travels faster through the medium. The second derivative with respect to x, y and z describe how the wave bends or changes shape in each spatial direction. Together, they determine how the wave propagates through three-dimensional space. Before solving the wave equation, we must know the starting position and the initial velocity of the wave. These are called the initial condition. Now imagine the wave travel inside a three-dimensional cube. The behavior of the wave depends on what happens at each boundary. The Dirichlet boundary keeps the displacement fixed. Think of the tightly clamped guitar string that cannot move at its end. The Neumann boundary fixes the slope or flux. Physically, it often represents an insulated or perfectly reflecting boundary. A Robin boundary combines both displacement and slopes. It is commonly used when the boundary interacts partially with its surrounding. Now, let's see the wave equation come to life. The blue surface represents the displacement of the wave as it evolves over time. Every point on the surface changes continuously. This motion is governed by the three-dimensional wave equation. The parameter c controls the speed of propagation. A larger value means the wave transfers faster through the medium. When the wave reaches the boundary of the domain, its behavior depends on the chosen boundary condition. It may reflect, remain fixed, or partially interact with the boundary. This is why the wave equation is fundamental in physics and engineering. It allows us to predict wave behavior in space and time. Thank you.